Welcome to cryptography session. Today I'm going to discuss a few algorithms under a basic mathematics of cryptography. So my mathematics of symmetric cryptography is divided into two concepts. One is general algorithm and another one is symmetric number theory concept. In a general algorithm, three types of problems are available. If you want to find out the GCD of two numbers, we can use Euclid's algorithm. And extended Euclid's algorithm, modular arithmetic concepts, congruence, set of residues, polynomial addition operations, additive inverse and multiplicative inverse. So these concepts are under a generalized algorithm. So here we want to find out additive inverse. Additive inverse means if you take two numbers, those numbers should be a set of residues of n given Zn. Those numbers, if you add those two numbers and if you do modulus operation by Zn, then the result should be 0. So here I am taking A and B. So this A and B should be the residues of Z10. And if you do A plus B mod 10, the answer should be 0. So what are all the numbers we can able to take it? For example, 0. Any number adding with 0 give 0 answer. So 0, 0. So 0th additive inverse is 0. If you take 1 and if you should add 9, 1 plus 9 is 10. 10 mod 10 is 0. So 1 additive inverse is 9. Like this, 2 additive inverse is 8 and 8 additive inverse is 2. So we can able to check in a reverse order also. So 3 and 7 are additive inverse of both. So additive inverse of 3 is 7. Additive inverse of 7 is 3. Which means that if you add A plus B, it should have 10 value or multiples of 10s. 4, 6, 5, 5. So these are the numbers. 6 is already had a additive inverse 7, 8, 9. So Z10 has only 10 values from 0 to 9. So all the values have additive inverse. Like this we can able to find out the multiplicative inverse, which means that the formula is A star B mod 10, that should be equivalent to 1. So if you take 0, 0 into anything 0, so there is no multiplicative inverse for 0. And if you take even numbers, if you do multiplication of those even numbers, the answer should be also even. So there is no possibility of getting a 1 as a remainder. So there is no multiplicative inverse of even numbers in Z10. So we can able to easily omit it. And 1 means 1 into 1, 1, 1 mod 10, 1. So 1 has an additive inverse. Next odd number is 3. So 3 into 7, 21. 21 mod 10 is 1. So multiplicative inverse of 3 is 7. Multiplicative inverse of 7 is 3. If you take 5, the 5 units values may be 0 or 5. If you do mod 10 operation, there is no possibility of 1. So there is no multiplicative inverse for 5. So we can omit it. 7 already had a multiplicative inverse. Then 9 means 9 into 9, 81. 81 mod 10 is 1. So only 3 pairs have a multiplicative inverse in Z10. Like this we can able to find out additive inverse of Z8. That means the fourth point. Z8 means the answers from 0 to 7. So 0 has 0. 1 means 1 plus 7, 8. So 1 pair is 7. 2 pair is 6. 3 means 5. 4 means 4. So only 5 additive inverse are possible in Z8. Like that we can able to find out multiplicative inverse. So Z8 means the set of residues values are from 0 to 7. 8 means its unit value should be even. So there is no possibility of getting one remainder. So there is no multiplicative inverse for even values in Z8. Then 1 means 1 into 1, 1 mod 8 is 1. So 1 multiplicative inverse is 1. If you take 3, 3 into 5, 15. 3 into 3, 9. So 9 mod 8, 1. So 3 multiplicative inverse is 3. Then we omit 4. If you take 5, 5 means 15, no, there is no possibility. 5 into 5, 25, it is 25 means 3 into 8, 24. So there may be the possibility of getting 1 remainder. So 5 means 5. 7 already has 7. 1 7 is 7. No possibility. 2 sevens are 14. No. 3 sevens are 21. There is no possibility of getting 1 remainder. 4 sevens are 28. No. 5 sevens are 35. No. 6 sevens are 42. No. 7 sevens are 49. Yeah, it's possible. So the answers are 1 1, 3 3, 5 5, 7 7. So only 4 pair has a multiplicative inverse in Z8. Then I will give the homework for you. You try to find additive inverse and multiplicative inverse in Z11 by using this Z10 and Z8 order. Okay. Then the third mathematical general concept is extended Euclidean algorithm. So this algorithm is especially used for finding the inverse of a given number. For example, I am taking an integer a. So that a is a set of one value of residue in Zn. So there may be the possibility of getting inverse, means if and only if GCD of n comma a mod n, that should be equivalent to 1. So how to find the multiplicative inverse of a particular number in Zn? For that purpose only we can go for extended Euclid's algorithm. In the previous thing, we directly find what are the possible multiplicative inverses. So if the n value is in single digit or 2 digit means it is possible. But if you take 3 digit or 4 digit of n, it is not possible like this to calculate it. For that only we should go for extended Euclid's algorithm. The formula is T1. We should take 3 different variables. T1, initial value of T1 is 0, initial value of T2 is 1, T equal to T1 minus Q into T2. Here Q means quotient. Then after calculating T value, copy T2 value to T1, T value to T2, like Euclid's algorithm. Okay. So for example, find multiplicative inverse of 11 in Z26. So you only find out the multiplicative inverse of 11 in Z26. So for this purpose, I should go for extended Euclidean algorithm. The same thing. So the first 4 parameters are like Euclidean algorithm. So you write that notation Q, R1, R2, R. So in this 2 number, the greatest number is 26. So that will be taken as R1. And I want to find a multiplicative inverse for 11. So that 11 number should be taken as R2. Then you do quotient and remainder calculation. Quotient is 2, remainder is 4. So this calculation is already done at Euclidean algorithm. So the same method that should be applicable in extended Euclidean algorithm. So that only this algorithm is called as extended Euclidean algorithm. So I'm additionally or extra, I add 3 different variables T1, T2, T. The initial value of T1 is 0. Initial value of T2 is 1. I want to find T. The formula is T equal to T1 minus Q into T2. Here T1 value is 0. Q value is 2. T2 value is 1. So 0 minus 2 into 1 minus 2. Then the first row is over. Then copy R2 to R1, R to R2. So 11, 4 are copied. Like that you copy T2 value to T1, T value to T2. Now we apply the same formula. So calculate quotient remainder. So the quotient remainders are 2 and 3. Same way we try to find T value. The formula is T1 minus Q into T2. So 1 minus 2 into minus 2. That means 1 plus 4. So the answer is 5. Once again copy the R2 to R1, R2, R2, T2 to T1, T to T2. Then quotient is 1, remainder is 1. The T value is T1 minus Q into T2. So minus 2 minus 5. So that is minus 7. Then copy R2 to R1, R2, R2, T2 to T1, T to T2. Then quotient is 3, remainder is minus 2. T 5 minus 3 into minus 7. So 5 plus 21. So 26. Then copy R2 to R1, R2 here. So that means here the number is 0. So I mistakenly write it as minus 2. So quotient is 3 means remainder should be 0. So if the 0 is copied to R2, the answer is 1, 0. Then we should copy T2 to T1 and T to T2. Then if you get the remainder 1, then check the T1 value. That is the multiplicative inverse of 11 in Z26. So if it is positive, you write it directly. Suppose if it is negative, then you do the same operation. The number is minus 7. So minus 7 mod 26. So you just add 26 with minus 7. Then the positive value is 19. So this is the 19 is the multiplicative inverse of 11 in Z26. In this way, we can able to find out the remaining notations for any number. So I am giving homework for you. So you try to find out the multiplicative inverse of 23 in Z100. So use the same methodology. The greatest number is 100. That should be taken as R1. 23 is taken as R2. Then you do quotient and remainder calculation. Then initial value of T1 is 0. T2 is 1. The formula for calculating T is equal to T1 minus Q into T2. So apply this formula up to the remainder 0. You try all this way. So if the T1 value is 1, so if that means if R1 value is 1, then you should take the T1 value. So if it is positive, you write as it is. So that is the multiplicative inverse of Z26. Suppose if it negative, then you do the same process. So like this you find out these values. So it's not necessary to get the multiplicative inverse for all the numbers. There may be the possibility of getting no inverse value. Like that, at that situation we should write it as there is no multiplicative inverse of the given number in Zn. So in this way we can able to do it. So these are all the problems which are all related to the previous basic mathematical algorithms. So I am giving these problems up to you. You try to understand the concept and find out the answers for these 5 problems. The next concept, basic mathematics of symmetric cryptography. So these concepts will be discussed in next session. Thanks for listening.